through a lot of detail, right? So that was, half hour, something like that, of getting down into the weeds in terms of some of the steps in the process and so on. So what I'd like to do is sort of, step back and look at the forest, right? And, we've been looking at, individual trees, right? That tree's odd. That tree has a mountain lion in it. This tree, some guy built his house in or something like that. But I really want to step back and, look at the forest, look at the big picture, and look at how we can apply this and what the P58 process and the associated USRC rig provides in terms of, what value that we can provide as a profession. So this is a design example. A similar process can be used for, looking at an existing building, particularly retrofit. But this is an example of, I have a new building, I want to design it. So let's say I want to design a 10-story wall, office occupancy, located at an LA site, right? So let's, pick some SDS and SD1 values. And my objective is 5-star everywhere. And starting off, who knows, is this possible? I mean, can we get 5-star everywhere by using a building like this? And do we have to base isolate? Would base isolation be better, blah, blah, blah. So let's look at it and let's see, look at a 10-story wall building. So our design objectives are 5-star everywhere. So that means less than 5% repair cost, less than 5-day recovery time, and then high safety, meaning collapse is taken care of, very few injuries, egress is taken care of. Okay, so step one, let's start with a code compliant design to see where that gets us. Right, let's start with what we're used to and see what our rating is for that. So for repair cost, average repair cost for this building would be 8%. So it gets a 4-star out the gate. And that's frankly because it's a wall, right? If you're looking at an office occupancy and you're using a wall, which is stiffer than a frame, you'll typically get better repair costs like that. If you used a frame, it would probably be higher in the 3-star range typically. So repair cost is looking okay. Repair time, now we're at 6 months, right? So the repair time is nowhere near the 5-day target. And the repair time really drives a lot of this when you go through and do these analyses. So the components that are sort of our problem components, it's actually a lot of the mechanical and electrical that is problematic in terms of getting back in the building in a functional way. So HVAC and so on. There is structural damage. So we've got a bunch of days of structural damage, and that's mostly to walls, a little bit to slab column connections in this building. And then also non-structural drift sensitive, so partitions, stairs, and so on. So there's a lot on recovery time that needs to be handled to get us to the 5-star, because we're sitting at 6 months, we're nowhere near 5 days. In terms of the safety, we'll get a 3-star safety rating if we track it through for this building, for a code compliant building. So the first step is we say, okay, well, I have a lot of structural damage, I've got a lot of partition damage and so on. So let's design the building to be very strong. Basically, let's make the inelastic rotations in the wall be low enough that there's essentially no structural damage at the 475 event. And if you want a 5-star, that's what it needs to be. As soon as you start triggering structural damage, there's no way it's going to be fixed within 5 days. So we do that. We also design the mechanical and electrical components to be functional at the 10 and 50. So we're going to have to increase anchorage strengths, perhaps modify some of the equipment in terms of the actual capacity of the equipment itself, make sure the lighting's better anchored and so on. And with those two steps, let's look at our updated results. So now we've gone from 8% to 5.5%, whatever. But we went from 180 days down to 70 days. So we've made a lot of progress so far. The current things, right, at this step is that slab column connections are still problematic and partition walls are still problematic in terms of the damage. And I think I may have lumped partition walls and finishes together in the 40 days. I'm not sure. But those two things, are the things that are problematic on the drip sensitive side typically. So, okay, I'm getting closer, but I'm not there. That 70-day needs to be 5-day. Okay, so what do I need to do next? One of the problems was the slab column connections. So I want to use a better slab column connection, right? Better meaning lower shear, which means the capacity is higher. So I need to make my gravity columns bigger. I need to make my slab thicker, something like that, in order to use the less damageable connection. And then I'm going to use a better detail on the partition walls, right? So the one we used in the P58 database is the fixed with friction connection. So let's use the better there. And so now for recovery, we went from 70 days to 40 days, right? So now we're still sitting at about 20 days for the slab column connections and partition walls. So what this is saying is that even if we detail the slab column connections, even if we, quasi-detail the partition walls, we can do better. But given standard ways that you do partition walls, pick the one that's the best. We're still not at 5 days. We're still at a little over a month of recovery time. So what we need to do is, because the two things that are impacting us are drift-sensitive components, we need to stiffen the building, right? So in this step, we stiffen the building, longer walls, more coupling, so on. And in this step, we reduced mean drifts at the 10 and 50 from about 1.5% down to about 1%. And the 1% in the beta testing that we've done seems to be about the target for buildings like this. Your mean drift needs to be about 1% or less if you want a 5-star performance in terms of achieving that. So we stiffened the building. We now reduced the repair costs, but we were okay there. But we did get to 5-star now. And now we have a recovery time of 2 days. So we're good to go now. We're below the 5 days. So now that we're there, let's see if we can loosen things up a little bit. Right, we already stiffened the building, so since I stiffened the shear walls, can I go back to the higher shear connections for the slab column gravity connections? Right, because my drift's lower now, so can I go back to that? And if I do that, it works, right, because I reduced the drifts, so I reduced the demands on those connections, so I can go to the higher shear connections. So I don't need bigger gravity columns, I don't need thicker slabs. Similarly, the building has less drift now, so let's see if we can move back to more damageable partitions. If we do that, it doesn't work, right? So we would have a 15-day recovery time. So we need to stick with the less damageable partition detail in order to keep with a 5-star performance. So now for safety checks, you have to go through and use the checklist to make sure collapse safety is enough and fatality rate's low enough. There's requirements for injury, residual drift, stairs and egress, and so on. And we won't go through all sort of the numbers here, but if you handle all these other things, primarily the thing that you need to do is make sure that falling items are anchored in order to make sure you meet these safety checks. So the basic outcome of this kind of iterative process, if you will, is repair cost of 2%, recovery time of 2 days, and safety rating of 5 stars. We haven't gone into the detail there. And this is an example for new design, but also useful for performance assessment as well.